know that those of you that don't have the note guide don't see this. The first graph that we're going to add to our parent function list is just the basic graph of y equals the sine of x. Okay? Now remember, we talked about why we saw the shape that we saw on our calculator when we graphed it. So we're basically just copying the very first thing that we graphed yesterday. But to understand it a little bit better, put a little chart here. It was important for us to know where it hit the axis, so what the 0 points were, and then it was important for us to know when it hit the maximum and the minimum points at like 1 and negative 1, okay? So think about when that happens with the sine function. So at 0 degrees, you get a sine of 0, and that's where it started here. Okay? And we're just going to go through one cycle of the graph. Okay? Then at 90 degrees, but we're going to talk about it in radians. So at pi over 2, it went up to 1. Okay? I'm going to go ahead and label this pi over 4, and then this one pi over 2. So if I shift by fourths, I have some marks in between. So notice I have enough marks here if I number by fourths that they basically represent angles that will take me all the way one time around the unit circle, which will be one cycle of all the sine values, and then they'll start repeating themselves, so I could just follow that pattern again as I went through. So I'm not going to really plug in pi over 4 because that's 45 degrees. I know the sine of 45 degrees is root 2 over 2, but is that like a convenient thing for me to graph on the graph? No. Okay? So I'm going to skip straight to 90 degrees or pi over 2 where I know the graph reaches 1. Okay? And that's where it reaches its maximum at 1. Okay? Then the next measurement I'm going to plug in is 180 degrees, or in radians pi. And then the sine at 180 degrees gets back to 0. Then the next one I would plug in is 270 degrees, or 3 pi over 2. And the sine there is negative 1, so that's where it reaches its minimum. And then 360 degrees, okay, or 2 pi. And again, that's back to the beginning, and the sine is 0. And at that point, the pattern would start repeating itself, and it would cycle through those numbers. Okay? So this is the basic parent function for the sine graph. Okay? Now, we're going to talk about a couple things either later today or tomorrow. 2 words we haven't used before, but we've been talking about them. They are the period and the amplitude of this graph. Okay? So the period of the graph means how long does it take for it to cycle through one complete cycle of the graph before it starts repeating itself. So you see that it starts at 0 here. Okay? It hits 0 again here, but is that a complete cycle? Do you just see it then repeating itself? No. It would be like that. Okay? And we don't see that. We see it go in a different direction. Then it gets here. Then would it start repeating itself? Yeah, because we've gone around the unit circle and picked out all the values, and then we'd go around again and pick out the same ones. So the period for the sine function is 1 time around the unit circle, or 2 pi. Okay? So again, the period just means how long it takes to get through the cycle. Okay? What kind of changes do you guys think are going to affect the period of the graph? So you know how we said yesterday, oh, we can put numbers here. We can put numbers here, put numbers there, we can put numbers there. So in all these spots, we can change the graph by putting in some value. Based on what you guys did yesterday and what you graphed, where do you think if I put a different number than 1 or 0 in that place is going to affect how long it takes the graph to get through a complete period or a complete cycle and start repeating itself? So look at the graphs that you graphed yesterday. Go back and look at the chart. So what does b do? In our different functions, when we put numbers inside the function that we're multiplying the x, what kind of transformation did those do to our function? Horizontal stretches or compressions, and that's what would change the period, right? Because it's going from this, and it's either going to take longer to go through it, or it's going to take less time to go through it. So later on, we're going to see a formula for how to quickly calculate the period, which is a nice thing for you to know, because if you know that it's supposed to be this shape, wouldn't you just like to know where it begins and ends, and then you can like draw the shape in appropriately? Okay, so we'll see how to do that, and it's going to depend on what the original period of the parent function is, 2 pi, and it's going to depend on the number that gets put in that spot right there that affects the horizontal stretching and compressing, which is b. So when we see that formula, don't be surprised that it only depends on b, because that's the only thing that stretches the waves out longer horizontally or makes them shorter horizontally. Everything else is just a change that affects direction or how high or when it starts and when it stops, but not how long it takes to complete the cycle. Okay? All right, now amplitude is kind of like how high your waves are from where like the middle axis is. So in the sine function, this dotted line doesn't really exist, but that's like where the axis is that everything kind of revolves around. That's the home base where there would be symmetry above and below, right? You see the same thing happening above this as you see happening below it, okay? And it's at 0 because we haven't shifted anything up or down. The amplitude is how high above that your maximum is or how far below that your minimum is, okay? The absolute value of that, okay? So right now, how high does the wave reach? 1 unit. And how low it reaches is down to -1, each a distance of 1 unit, okay? Which functions in your graphs yesterday changed the fact that it only went kind of 1 unit away from the middle? So when you graphed it, when did it reach higher or lower than that? When the a value changed, right? Those first ones with 3 and -3 in front for the a value, okay? Good. And since amplitude doesn't just measure this one or just measure this one, we don't really say a negative or a positive with it. We just say, hey, wherever the center ends up being, your maximum is 3 above that and your minimum is 3 below that. We just want the measurement of like 3 or 1. So what we do is we just take the a value, which totally is the only thing that affects that, and put absolute value bars around it. Now, my graph couldn't reach 3 without being stretched if I move the whole thing up. But if I move the whole thing up, that's going to change like where this middle part is, but it's not going to change the fact that the amplitude was still just 1. Okay, we just moved up the entire graph. But the a value actually stretches the maximums and minimums further away from this kind of middle axis that's going through our waves. Okay? So we're going to hear words about period and amplitude. And in this parent function, the amplitude is just 1. So what it's going to be important for you to know about each of your 6 parent functions. You're going to want to be able to build a cycle of the graph, okay, a period of the graph, which is going to depend on what the actual period is. You're going to want to know where it starts and stops and the maximums and minimums that it reaches. And you're going to want to know basically these 5 points to put on there. Okay? So when I memorize the sine function as a parent function, I know that it looks like this, right? But I want to know it starts at 0, 0, and then goes up, back down, down, and then back to the starting spot. Okay? Does that make sense? And that's by every like 90 degrees or pi over 2 that it does that. Because every graph I go to graph that has sine in it, I'm going to start with this arrangement. Then I'm going to stretch it or compress it, shift it, reflect it, whatever I have to do with it. But if I know how to start with this and I know what all the different numbers do in the equation, then I'll be fine. Okay? Is this okay with everybody? So we're going to just keep this record sheet for each function. Like, here's the sine function. I have to know this. I have to start with this every time. And we want to know these 2 things about it, like its period and its amplitude. Okay? Now, the graph continues to the right and to the left. But we're going to focus on drawing 1 period of the graph. And then when you have to make your graph extend, once you've done everything to it and you have it in the right place, then you just copy the pattern of the points to the right and to the left. Okay, so we're going to focus on 1 period of the graph, and then we'll copy it where we need to copy that pattern later. Okay? Any questions on the parent function part of it? Okay, so the people that recognized what A did and what B did by what we graphed yesterday, okay, you were seeing the differences between the graphs, but I want to make sure that we're all there. So what I want you guys to do right now in your group is I want you to look through the graphs that you did yesterday, all 10 of them. Some of them changed the A value, and look at what happened to the graph. Some of them changed the B value. Look at what happened to the graph. So I want you as a group to come up with this information. A does this to the graph. B does this to the graph. H does this to the graph. And K does this to the graph. If we don't remember or know what these things do to the graph, then all we're going to be able to do is get this every time, and then we're not going to be able to get it in its new position with whatever the numbers are in the equation that have moved it around a little bit. Does that make sense? So right now in your groups, when you're done talking, everyone should be able to tell me A does this to the graph, B does this to the graph, H does this to the graph, K does this to the graph. Make sense? Yes? Okay, so talk with your group until you can complete those 4 sentences. Okay? All right, go for it.